Hello and welcome to Open Book. In this video we are going to talk about the Perseverance rover that has landed into Mars at February 18, 2021. This video would have not been made without my fellow subscribers. If you are new to this channel, consider subscribing for more exciting video like this. The parachute has a series code known as binary code. By decoding this, one must first divide the section on the ring into 8 pieces, like this, where each has a 7-digit in every 3 blank space. The first section of the ring has 4 pieces which are lower than the number 26. Higher number than 26 are called junk code. Their numbers represent the placement at the alphabet. The first word given is dare. The second section with 6 pieces is mighty. And the third section with also 6 pieces is things, which translate to dare mighty things. The motto of JPL. The outermost section are the coordinates of the JPL lab at Pasadena, California. This hidden message was first discovered by a user at Twitter who notices the orange and white pattern at the parachute. During the 7 minutes of terror, which is actually referred to the entry, descent and landing phase of the rover, as the events take place much quicker than the radio signals can reach Earth from Mars for communication. During this time, the descent stage is expected to be re-entering the Martian atmosphere. At this phase, the craft is accelerating at hypersonic speed. 90 seconds after entering the Martian atmosphere, the craft preparing to deploy its parachute. During this time, the onboard camera is recording the flight data. 240 seconds after the parachute deployment, the craft is preparing to separate the heat shield. During this time also, the rover's camera will be recording the ground below. In 260 seconds the heat shield is deployed, exposing the rover's radar. At the same time, the rover is separated from the back shell, enabling the power descent and off course to its landing site, with only a minute away to its destined landing site. The rover's camera is recording every bit of its flight path all the way until it hits touchdown. The craft is accelerating only at 17 miles per hour or 27 kilometers per hour, which is considered safe for touchdown. Once it hits touchdown, the sky crane detach, then fly away farther from the rover, marking the end of 7 minutes terror. This right here is the actual footage taken and sent by the rover the day after its touchdown, as well as multiple angles from the sky crane and above the rover. This marks the first video footage taken from Mars and with multiple angles. However, the Audi was missing during its descent. This footage enables the JPL team for the first time to track the condition of the rover where one cannot see fully during its descent. Ingenuity, a technology demonstration experiment, will be the first aircraft to attempt powered, controlled flight on another planet. Its achievement will be equivalent to the Wright brother. Ingenuity arrived at Mars on February 18, 2021, attached to the belly of the Perseverance rover. Ingenuity is expected to attempt its first flight test in spring 2021. After deployment, The rover is expected to drive approximately 100 meters or 330 feet away from the drone to allow it a safe buffer zone in which it will attempt to fly. It will use autonomous control during its short flights, although flights will be telerobotically planned and scripted by operators at the JPL in up to 90 seconds per flight. It could travel as far as 50 meters or 160 feet downrange and then back to the starting area. Because the atmosphere of Mars is only about one as dense as that of Earth at surface level, it is much harder for an aircraft to generate lift, a difficulty only partially offset by Mars' lower gravity. Liftoff from Mars' surface has been described as equivalent to flying at 100,000 feet or 30,000 meters above Earth, an altitude that has never been reached by existing helicopters. Sensors collect data on how fast the Ingenuity is traveling and in which direction. It includes a lidar and inertial sensor. On the other hand, another is the two cameras that will help the helicopter see and record while from above. This is also a wide angle that will capture a wide field of view above. The camera is connected to the avionic. Its avionics or brain helps it function and navigate. The body has an insulation and heater to keep the sensitive electronics warm and to survive the cold Martian night. The battery is also located to the body. Without a landing pad, the helicopter have 4 carbon fiber legs to help it stand and land. And it uses a carbon fiber blade in contra-rotating coaxial rotors to enable it fly. The solar panel enable it to recharges the battery after flight and for extended use, while the antenna is located above the solar panel in order to communicate through the Perseverance rover into Mars orbiter. The Ingenuity is 1'7" in tall and has a rotor of 4 feet in diameter. In comparison, the Perseverance rover is 7 feet 3 in height. It will communicate with the Perseverance rover directly after each landing. If it works as expected, NASA could build on Ingenuity's design to extend the aerial component of future Mars missions. They could offer a unique viewpoint not provided by current orbiters high overhead or by rovers and landers on the ground. Provide a high-def images and reconnaissance, and enable access to terrain that is difficult for rovers to reach. The Perseverance rover carries 2 microphones on board and is set to land on the Red Planet on February 18, 2021. One mic has already sent back a test clip, recorded en route. This is the first time a rover sent an audio from Mars to Earth. The Perseverance rover has several cameras focused on engineering and science tasks. It has a total of 23 cameras. 7 are for the EDL. On engineering camera there is a cache cam located inside the rover for analyzing the sample tube. The super camera fires a laser at mineral targets and then analyzes the vaporized rock to reveal its elemental composition. 2 stereo navigation camera help engineers navigate Perseverance safely. And the mast camera Z, a pair of cameras that takes color images and video, 3D stereo images, and has a powerful zoom lens. There are 4 front hazard avoidance camera to detect hazard, and also on 2 rear of the rover body. The planetary instrument for X-ray lithochemistry is called Pixel. Pixel has a tool called an X-ray spectrometer. It identifies chemical elements at a tiny scale. The scanning habitable environments with Raman luminescence for organics chemicals has a nickname, SHERLOC. Mounted on the rover's robotic arm, SHERLOC uses cameras, spectrometers, and a laser to search for organics and minerals that have been altered by watery environments and may be signs of past microbial life. SHERLOC is assisted by Watson, a color camera for taking close-up images of rock grains and surface textures. The 7-foot or 2.1-meter long robotic arm on Perseverance can move a lot like human. It has a shoulder, elbow and wrist joints for maximum flexibility. The arm lets the rover work as a human geologist would, by holding and using science tools with its hand or turret. The rover's drill will use rotary motion with or without percussion to penetrate into the Martian surface to collect the precious samples. A big job for the rover is collecting carefully selected samples of Mars rock and soil. The belly of the rover houses all the equipment and supplies needed to collect samples. It contains a rotating drill carousel, which is a wheel that contains different kinds of drill bits. Perseverance carries 5 witness tubes. The witness tubes are similar to the sample tubes except they are preloaded with a variety of witness materials that can capture molecular and particulate contaminants. While the rover's big arm reaches out and drills rock, the rover belly is home to a small robotic arm that works as a lab assistant to the big arm. The small arm picks up and moves new sample tubes to the drill, and transfers filled sample containers into a space where they are sealed and stored. There are 43 sample containers waiting to be filled, and once the tube is hermetically sealed, nothing can enter or leave it. The tubes are stored in the rover belly until the team decides on the time and place to drop the samples off on the surface. At a time and place of the team's choosing, the samples are deposited on the surface of Mars at a spot that the team designates as a sample cache depot. There are at least 20 samples to be collected. This entire process is called sample caching. Mars 2020 will be the first mission to demonstrate this on Mars. It could potentially pave the way for future missions that could collect the samples and return them to Earth for intensive laboratory analysis. The Mars Oxygen in Situ Resource Utilization Experiment is better known as MOXIE. NASA is preparing for human exploration of Mars, and MOXIE will demonstrate a way that future explorers might produce oxygen from the Martian atmosphere for propellant and for breathing. MOXIE makes oxygen like a tree does. It inhales carbon dioxide and exhales oxygen. Homemade liquid oxygen on Mars could supply more than 3/4 of the propellant humans need for exploration on the red planet. MOXIE is the size of a car battery. Future oxygen generators that support human missions on Mars must be about 100 times larger. The filter, which works like an air purifier, connects at the scroll compressor where it feeds carbon dioxide and turn it into compressed gas, where it will then go to SOXIE for electrolysis. It rotates at 3,500 revolutions per minute and feeds 0.18 pounds of CO2 per hour, where pressure increase at 0.7 bars at 158 Fahrenheit. The solid oxide electrolysis or SOXIE splits CO2 into O2 and CO. It works when elevated temperature. Certain ceramic oxides, such as YTTRIA stabilized zirconia or YSZ, become oxide ion, liberating the oxygen atom at a carbon dioxide. The sensor panel then regulates its process during oxygen making. Oxygen produced on Mars could help support the breathing air supply for human explorers and its propellant in the future. NASA has used similar power systems reliably for decades, including the Apollo missions to the Moon, the Viking and Curiosity missions to Mars, and others. The MMRTG provides power for the Mars rover using plutonium. The 14-year operational lifetime provides significant reserve for Mars 2020 prime mission duration of 1.5 Mars years or 3 Earth years. This power system charges the rover's 2 primary batteries. The Perseverance rover has several embellishments, which were thoughtfully chosen, designed and then etched onto pieces of titanium or aluminum. Some designs celebrate past missions, while others offer hope for future human achievements on Mars. The following are the Explorer as one plate with a memory card containing the names of 11 million. The Perseverance nameplate. The Rover Revolution plate. The United States flag. The JPL logo. The NASA insignia plate. Bringing back a piece of Mars plate. Tribute to Healthcare Workers plate. And Sherlock calibration target. We hope you like our video. If you want for more quality video like this, consider subscribing by clicking the channel icon. You can watch the playlist for more videos. See you until then.